Okay, this is Mr. Sitta. I'm continuing to work on the alternate review for Chapter 5, Thermochemistry. I'm on problem number 15. 1 through 14 will be on the first videotape. This problem, Q equals 29 grams, joules, mass equals 15 grams, and temperature initial is equal to 22. Now, the temperature increases to 22, so TF equals 37. Sorry, it went to 37. Now they want to know what the CP is. CP equals question mark. So I'm going to use the thermo equation. Q equals CP times M times delta T. And I'm going to solve for CP. So algebraically, CP equals, divide both sides by mass and delta T. Mass and delta T equals Q divided by mass divided by delta T. So pretty much the opposite of this problem. 29 joules divided by 15 grams, then divided by the delta T, subtracting those two things, is 15 degrees. And I'll just call it Kelvin now. So I'll say 15 Kelvin. And so my answer equals 0.13 joules per gram per Kelvin. And that's your CP of lead. Okay. 16. I have 2 samples of water, so I'll draw a little picture. Help you understand. I dump this water into that water, so heat comes from the higher one into the lower one. So Q goes from here to here. Okay. What I can do is say, we'll call this mass 1, we'll call this one mass 2. So Q1 equals CP times mass 1 times delta T1. And then in the second one, Q2 equals CP times mass 2 times delta T2. Okay. We can just end up saying that the Q of 1, which is negative, is going to equal the positive Q of 2. So I'll make these two things equal to each other. So CP times mass of 1 times delta T1, and I'll put a negative in front of this, equals CP times mass 2 times delta T2. The CP I can just get rid of, it's going to cancel out. You can make a list of things you know. Mass 1 was equal to 55 grams. Okay, your T1, your T initial is 69 degrees Celsius. So your T final is 31. So my change in temperature here is it went down 38 degrees. So I'll say the delta T is a negative. I'll put a sign on that. It ends up being that a negative times a negative is a positive. So these things just end up equaling each other. So we want to solve for M2. I can say that this equals that divided by delta T2. So you got 55 grams times 38 degrees Celsius divided by your other temperature change equals mass 2. The other temperature change, it starts at 22, it goes up to 31, so it's a positive 9 degrees. That'll give me an answer. 55 times 38 divided by 9 equals 232. Okay, and again, my signs, I had originally made this a negative, and so this temperature change was a negative, and negative times negative makes a positive. Okay, this is used in calorimetry. When you take the heat of one and make it equal to the heat of the other, that's the basis for like calorimetry in a lab. You can take one object, put it into another, and the heat going from one equals the heat of the other. Okay. Q equals number 17, 75.73.51 joules. Mass equals 250.6. These are very easy questions. They want to know the final temperature, so I'll just say, let's find the delta T. The fact that heat is added tells me that this temperature is going up, so I don't have to mess around saying T final minus T initial. All I'm going to do is find the delta T. Okay, we're going to use the calorimetry equation, C equals Cp times M times delta T. We're going to solve for delta T, so we'll divide both sides by Cp and M. Plug in my numbers. The change in temperature equals 73.51 joules. Big thing, make sure that that Q is in joules. Later on in other problems you'll see if you got it in kJs you need to convert it to joules. Cp of water is 4.184 joules per gram degrees Celsius, and the mass is 256, 25.6 grams. So the grams cancels out, and the unit, the joules cancels out, and the unit I'm going to have is going to be degrees Celsius. 1 divided by 1 divided by degrees Celsius equals degrees Celsius, because when you divide by a fraction you invert and multiply. So that's what's going on with your units. 73.5 divided by 4.184 divided by 25.6, 0.686. Okay, now up to there I have 3 sig figs. I know I'm going to add it to this temperature. So now I just know that it's exothermic, so it's going to add. So I can cut this off and round it up. So the answer just comes to be 26.0 degrees Celsius, because I don't know the thousandths or the hundredths place. And so the answer is A. Keep rolling. Alright. More calorimetry, which kind of gets really old. Q equals 127.2 joules. Mass equals 152.6 grams. Again, they're asking you for the final temperature, so I'm going to just find the change in temperature. So from the last equation, change in temperature equals Q divided by Cp divided by M. That comes from Q equals Cp times M times delta T. That's what we're using for all these. So we got 127.2 joules divided by the Cp of water, 4.184, divided by the mass, which is 152.6. I'm not going to do anything with that initial temperature, but heat is added, so just like the last problem, the temperature is going up. So I'm going to add this to that number, 127.2 divided by 4.184 divided by 152.6. I get 0.199. Now I'm going to add that to 25.3 because it tells you that the heat was added. If it says the heat was removed, then I would subtract it, okay, because I know that the temperature is going down. Plus 25.3, I get 25.499, which is going to round to 25.5 degrees Celsius, because I only know this to the tenths place, so D. Alright, I'm getting tired of these problems. Alright, mass equals question mark grams. The change in temp is 5 degrees Celsius, 5.0. The amount of Q is 324 joules. Yeah, now I'm bored. I know the Cp and I want to solve for M. So mass equals Q divided by Cp divided by your delta T. So I know that I got 324 joules. Cp of water is 4.184. And then I'm not going to really look at units. 5 degrees Celsius. So the answer is 324 divided by 4.184 divided by 5. Answer is 15.5. And grams. A. Okay, we're off that. Thank goodness. I'm giving you the specific heat of water. of liquid bromine, 0.226 joules per gram per Kelvin. Now this is bromine, so it's Br2, which is diatomic. They want the molar heat capacity. This is on the same worksheet, so they want to know joules. But instead of having grams, they want it in moles of bromine per K. So this is just a quick dimensional analysis. I'm going to convert this conversion factor to a new one, converting grams to joules. If grams is on the bottom, grams goes on top. And I want to convert grams to moles. And the molar mass of bromine is 79.9 times 2, so it's 158.8 or 159. 159.8 to 1. The grams cancels out, becomes a mole, and all we did was a unit conversion. So the answer is 0.226 times 159.8, 36.1. B. Don't get too bugged by it. 21. If I was doing a lab, I would have done 21 as a lab. And 21 is actually your simulated lab. So if you look at the simulated lab calcs, you'll see how to do this. Now, the heat of solution for sodium hydroxide is 44.4, and I have 13.9 grams, and I believe that should be a negative. I know it's exothermic. Okay, so I can use dimensional analysis to convert that 13.9 grams into kJs. So this is NaOH. So I know that a gram per mole is 40.0 to 1. That's the molar mass of sodium hydroxide. And then I need to go from a mole to a kJ. Now this is the heat of the solution. If I just put it in water, it's 44.4 to 1. So I got 13.9 divided by 40 times 44.4. I got 15.4, and that's the Q. That's as opposed to this is using the delta H, which is kilojoules per mole, to just find the amount of heat, which is 15.4. Now, for the rest of the problem, you see a temperature measured, and they want to know the final temperature. So for the rest of the problem, I want to use Q equals Cp times M times delta T. This part of the problem got you Q. The one thing is your Q's in kJs, and this Q's got to be in joules. So I want to convert kJs to joules, so I want to multiply by 1,000. So Q in kJs is 15,400 joules, in joules. Okay, so we're going to solve for the delta T. Delta T equals Q divided by my Cp divided by my mass. And the Q is 15,400 joules. Most kids' biggest mistake in this thing is you don't convert from kJs. So they're going to put 15.4 kJs in there, and they're going to be wrong. The Cp of water is 4.184, and we're going to assume that most of the solution is water, so they just say use 4.184. The mass, well, the mass equals that 13.9 grams of solute plus, they say 250 grams of water. Well, that's solvent. So together you get 263.9 grams of solution. So I want to use 263.9 for the bottom grams. You're adding your solute and your solvent. So you get 15,400 divided by 4.184 divided by 263.9, and I got my change in temperature is 13.9 degrees. Now I know this is, it should have said negative up here, so I know it's an exothermic reaction. So I'm going to add that to my initial temperature, so the temperature is 23 plus 13.9. So you end up with 36.9 degrees Celsius D as a final temperature. All right, we hit 22, and now we're going into Hess's law. I want to take these two reactions and make it add up to the third reaction. Now here's 2E's liquid, and there it is. So this number is okay, don't have to change it. I'm going to look at each one individually. There's oxygen. I have oxygen here, oxygen there. I'm just going to leave it alone. I know that this one can't be touched, so actually I know in my head that this one's got to be multiplied by 2. But I'm going to fix it from this problem over here. EO3 is over on the right already where it belongs. It needs a 2 as a coefficient. So I'm going to multiply everything here by 2. There goes your oxygen. 2, 2. And so I need to multiply the delta H by 2. So 196 times 2 equals negative 392. Now I'm going to do Heat's law summation. I'm going to just add these two numbers up. Plus negative 333. And the answer I get is that the delta H here equals negative 725 kJs. D. If I want to check my math, there's your EO2 on the right. These aren't lined up real well. 2 plus 1 equals 3. There's your 2E's. And the EO, well, that cancels out. So everything, these two equations add to that one. Good deal. Keep rolling. Okay. Just one more page, 2 more pages. Okay, I want these two reactions to add up to this third reaction, so I'm looking for the delta H reaction of this. Okay, I'll start with the Fe2O3. It's right here, but it needs a coefficient of 3, so I'm going to multiply everything by 3, which is 9, 6, 9. I multiply my delta H by 3. 3 times 28 is negative 84 kJs. Here's your CO. I'm going to leave CO alone. Too confusing for me. I got it there, I got it there. Just leave it alone. It'll all come out in the wash. CO2 is right here. And again, I have CO2 there and there, so I'm going to leave CO2 alone. If I start trying to mess with that, you know, you're gonna be like all over the place. I know Fe3O4 right here is right there, and now I can simply see that I need to double everything. So 2 makes that an 8, makes that an 8, puts a 2 there, double my delta T, so I get positive 25 kJs. Now I'm pretty much done. I know that 84 added to 25 equals negative 59. The answer is A. I can recheck to see how everything worked out. Your Fe2O3 ended up there as a 2. The CO, 8 of these canceled out with 9 to just make 1 CO. There it is. The CO2, 8 of these canceled out with everything but 1 of these to leave you with 1 on the right. I mean, I could get them from there, but it's just keep it simple. And your Fe2O3 is right there. Okay. These two equations to get to this equation, I'm looking for this delta H reaction. This is Hess's law. N2 is on the left. It's nowhere else, so this reaction stays the way it is. Okay. O2's in 2 places. I'm going to leave it alone. Okay. You know, if I saw that it's becoming a 1, I can see that I have to switch this one to have it subtract 1. But it's just easier to say, here's the NO. The NO is on the wrong side, so I'm going to take this entire equation and flip it. So I get 2NO2 on the left as a reactant. As a product, I get 2NO plus your O2. And there's your O2. When you add them up, it cancels out. Okay, just one of them cancel out. Okay, your NO2 ends up canceling out. Your NO ends up where you want it on the right. Your oxygen, the one that's left, ends up there, and he ends up. And when I switch this, I have to change the sign to a positive. So I take 66.4 plus 114.2. So I got 180.6, and it's positive. I always want to put a sign either if it's positive or negative. I like to see signs on these. I'd rather see a positive there with that. Okay, that ends Hess's law. And this ends with heat of formation. And the equation, whenever you see a heat of formation problem, you're going to be given your delta HFs. If you were in your textbook, you would have to look those up on Appendix C, page 1041. Okay, so calculate the heat of reaction. I always tell students, I go, write down the equation, please. Delta H reaction equals the sum of the number of moles of your delta HF of your products minus the N delta HF of your reactants. And so it's just a matter of plugging this in. Your reactants are here. Your products are here. It gives you a lot more than you have on there. So we'll start off with the products. You got 4 times NO and 6 times. So 4 times NO will be 4 times 90. So I got 4 times positive 90. Going to add that up to the water. I have 6 waters. Now, this is water as a liquid. As a gas, it's 241, so you got to be careful of the state when you're looking these up. This is 286 negative. So if I go 4 times 90 is 360. 6 times negative 286. This would be minus 1716. So for my products, I have 1416 negative. Now let's do the reactants. Minus, the reactants are NH3, so ammonia is times 4. So you got 4 times negative 46. So I got a negative, this would be 4 times negative 46 and plus 0. The heat of formation of an element like oxygen, the delta HF, the question you answer yourself is, heat of formation is how much does it take to make any compound out of its elements? Well, oxygen is a gas. It's already a gas, so the delta HF is 0 kJs per mole. So if I have something elemental, they're not going to list it. They're going to expect you to know that O2 is a 0. Okay? And so this number becomes negative times a negative will be plus. This is minus negative 184. So it'll be plus 184. And that's your reactants. And whichever one is higher, that's going to be your sign. And the reactants are more negative, so the answer is negative 123, 2. Let me check that. 6 times 286.